All right, linked lists, because I like linked lists, so that's what we're going to talk about today. So we're going to start by talking about kind of like contiguous memory and what that is. So contiguous memory is kind of memory that's stored like next to each other in memory. So they're all kind of stored next to each other. This would be in something like, this is something you might find in an array or in a vector or something like that. Some pros to contiguous memory is like indexing is very easy. You just have an array, and you just call what index you want, and you're like, boom, you're done. It's like super easy. Some cons though is if you want to like increase the capacity of say your array, it doesn't work super well because you have to you have to take your values of 1, 2, 3, and 4. You have to make a new array, and then you can add the values in there. It's not the most efficient method to do things. And then if you want to add values in the middle, so say we have list, say 1, 2, 3, and then 5, and then we want to add the value 4 in there. See, we still have like that there, but like you have to move all the values down, all the values below where you want to add it down. So we would have 1, 2, 3, you have to move 5 down, and then you can add the value 4 here. And that is also not the most efficient way to do things. So the other kind of memory that's non-contiguous, or the other type of list, I'm sorry, non-contiguous is not next to each other in memory. So it's much more, it could be next to each other in memory, or it could be very much kind of scattered throughout. And then like it consists of like a pointer that points to that and points to that, and that's null, doesn't point to anything, because that would be the end of like the list. And so the way that this kind of works is that consists of like a node. Each sort of like point is a node. Each node contains some sort of like datum, which is the value that you're storing there. Either maybe like an integer, maybe you're storing the value like 3, like an integer like that, maybe some sort of string, whatever it is. And then it contains like a pointer. So you're like your next pointer. So your node next, which would point to the next one in memory. So this right here, that's your node, and it points to this node. That's your node pointer. There's your node. And then same thing with this one down here. It points to this node. And then because this is the end of the list, it's a null pointer. It doesn't point to another node. And so because of this, hold on, let's just clean this up a little bit. Make it a little easier to see. So we have our 1, our pointer, our next node, 2. Let's say that one's null. So this points to that. And so an advantage of this is kind of a disadvantage of contiguous memory is kind of adding values in the middle. It's slow. So what you can do, so we just make like our new node. This one will store 3. So I guess we'll have 1, 3, 2 out of order. You have another pointer. So this is like our datum. That's the next value. And so what you can do, you can set next to point to the next node, which is node 2. And then we can just change where this node pointer points to. And it points to that one. And now you've added the value in the middle. No real hassle. And so there's this kind of like, linked lists are nice, they're good for that. Indexing is a little more complicated because you have to jump from pointer to pointer. So you have to follow where this pointer goes to get to this node, to follow where that pointer goes to get to the next node, and then you reach like the end of the list. So non-contiguous memory, it doesn't index quite as easily. or it doesn't index as well as contiguous memory, but it's much easier to add new values. And then if you want to just increase the size of it, I mean, we did here. It's just as simple as creating another node, like a pointer, and then just redirecting a pointer to that one. And that is kind of the basics of contiguous and non-contiguous memory and linked lists.